ecosystems are composed of two elements, as was indicated in the prior slide when we were talking about Walter the Moose. One of those components is the abiotic, the non-living component of the planet, and the other is the biotic, or anything that is living or once was living. All right, so organic material, dead leaves, things that were dead, roots, things like that are considered biotic, or are biotic. So abiotic is going to be sunlight, it's going to be water, it's going to be nutrients such as potassium and phosphorus, and those move through cycles. So the geocycle. So there's a potassium cycle and a phosphorus cycle that can be traced and recognized how these things move through the planet. To focus on the biotic with ecosystems in this chapter, we look at a number of different elements within the biotic, and those are producers and consumers and decomposers for the most part. Within the consumers element of the cycle, there are three of those. There are herbivores, or consider the vegetarians. There are carnivores, the meatitarians, if you like that term. Those are predators, essentially. And then omnivores, those entities which are opportunists, and they eat both flesh and plant matter. So within the cycle that makes up ecosystems, sunlight comes in, it drives the hydrological cycle. Plants take up solar energy and produce matter with it, and that matter then is consumed by herbivores. All right, so consider squirrels and rabbits and ducks, the individuals who are the primary consumers are the herbivores. Those herbivores and those producers go through their own life cycles that uptake energy, uptake matter. Those plants shed organic matter, then that organic matter then gets cycled back into the earth and then taken up again. If that matter is consumed by a primary consumer, an herbivore, then that energy is taken into the cellular structure of that organism. That rabbit, as the screen indicates, is taken by that rabbit, and that rabbit's going to use it in a number of different ways. It's going to use it for reproduction, for running, for eating more food, just the biologic everyday living components, to include defecation and urination. And it's through defecation and urination that some of that primary producers, those plants, get cycled back into the system, where the plants take that nutrient back up eventually. If that animal, if that primary consumer is consumed itself with a with a secondary consumer, so a carnivore or an omnivore, then its energy and matter is taken by that organism, and that organism's mechanism of its life cycle, just the everyday goings about with that animal, including defecation and urination and eventually death, will result in all of that matter going back into the system to be retaken up. Upon death, decay, or defecation, then the big agents of our planet, the decomposers, fungi, bacteria, are going to take up that matter, decompose it back down into its nutrient elements, and allow it then to be ready for the primary producers to take back up as it's moving through the gaseous cycles of our planet, so the atmosphere, through the hydrological cycles, if we're moving it through as water, or through the geocycles like the phosphorus cycles. So this then completes the loop, because all of those once organic elements are now reintroduced back into the start of the cycle, where primary producers can take it up. This looks like a nice tidy loop, but it goes back to what we were saying in terms of there are multiple pathways for which this can be undertaken. and we often consider those pathways food webs. Historically or traditionally, we used to call things a food cycle or the food chain, but a food web is much more appropriate because the organisms that are out on the system are going to take up matter and energy in any way they can. Particularly if you are a generalist. If you are a species that doesn't have a lot of opportunities to eat your preferred food, you're going to take advantage of whatever comes along. And I always think of the high Arctic here. You're a polar bear out on the Arctic ice, and a seal comes along, and you would really rather prefer to have a Arctic fox for lunch. Well, that Arctic fox may never come along. You're going to take advantage of the Arctic seal for dinner. And that may be your only dinner for many, many weeks. So you are not going to be selective. You're going to be generalistic, and therefore you're going to take anything that's available to you. So it's more of a web than a linear A eats B equals C. It's A can eat B, D, F, or Q, essentially. So the diagram of the food web on this slide does a pretty good job of showing how many different ways an organism can be consumed in a network rather than a linear cycle. So I mentioned generalists. Specialists, on the other hand, can be more linear, but generally aren't so linear that there's only one thing that they eat. They just have a more narrow range of elements that they're going to consume. So we can look at the classic Darwin's finches, and Darwin recognized by the structure of the finches on his travels that there were finches with long, slender beaks, and those particular finches only consumed berries. But they didn't consume just one or two types of berries. They consumed many different berries from many different trees, and that was important because, as I said a while ago, that those trees are in competition with each other for energy. So they're going to germinate at different times. So different berries are going to mature at different times, which is beneficial to Darwin's finches because that means they have food available to them through an entire season. Darwin also noticed that there were finches that had shorter bills, more robust beaks, and those individuals, those species, consume primarily nuts. So there wasn't competition between the two primary types of finches. One group of species ate nuts, and one group of species ate berries. And amongst all of the nut eaters, there wasn't a lot of competition between individual nut eating birds because they were selective in what they could eat. But again, they could eat a number of different types of nuts. But we're only limited to nuts, or we're only limited to berries. That is a specialist. So finally, when talking about the movement of energy through food webs, and whether you're a specialist or whether you're a generalist, is this idea of trophic levels. And at the bottom of the trophic level, and this is an ocean ecosystem example here, is we've got all of this variety of plankton, lots and lots of different species of plankton, hundreds of species of plankton, as a matter of fact. Most abundant animal organism on the planet is plankton, and so that is able to take up solar energy, and we've got billions of metric tons of it out in the oceans, and that then gets consumed by a smaller number of species. We've got an example of shrimp and squid in this example here, but what we find is of all of the plankton, in this case, the values that we're giving here is 1,000 kilograms of plankton will feed 100 kilograms worth of these predators, right? And so that tells me that there's some volume of matter that's lost. And it's not lost, it's just transferred into the system by the very being of living. So, you're breathing and you're moving and you're thinking. That energy that is used up by the consumption that the plankton undertake, then only 10% of that gets manifested into the cellular structure of their consumer, because their consumer then, that 90% is going into the day-to-day living, right? So of these consumers, they get consumed by this illustration of some tuna, and we get a loss of 90%. 10% of the body weight of tuna is made up of 100 kilograms of who they've eaten. So again, one would argue, oh, we've lost 90%. No, that 90% wasn't lost. It was used in the functioning, the swimming, the predatory actions of this species going about its day-to-day living. Only 10% of that matter was manifested into the body. And then, Dave or whomever comes up here, he fishes for a single tuna. Dave's weight is only 1 kilogram of weight gain, even though he ate 10 kilograms, or he acquired 10 kilograms of fish. The other 9 kilograms, or 90% of what was used, went into Dave going fishing, Dave traveling to work, Dave thinking at work and doing whatever he needed at work, and going home and playing with his kids. All of those things wrap up into the consumption. So this is a trophic level where the physical entity only transfers 10% of its cellular structure onto the cellular structure of the next organism that consumed it.